Hi guys, and welcome to section 4 of this course where we'll be taking a look at the Amazon Compute services available to us on the platform. In this section, we'll be taking a look at the Amazon Elastic Compute Cloud, EC2, the Amazon EC2 Container Service, Amazon ECS, Amazon Elastic Beanstalk, Lambda, Lightsail, and the AWS Batch Service. So, let's get started with taking a look at the Amazon Elastic Compute Cloud EC2 service and move on to seeing exactly how we provision our EC2 instances in the cloud and how we configure them. So what is the Amazon Elastic Compute Cloud service? Well, it is a virtual service solution in the cloud. EC2 gives you complete control over your computing resources from the OS level up, and you get to manage all OS level functions like installing updates and patches and installing applications and so on. You don't need to worry about investing in hardware up front. You are charged on a utility model based on an hourly usage. As such, Amazon EC2 can enable your organization to swiftly migrate from a CapEx mode to an OpEx mode of investment in IT infrastructure. You have access to various operating systems comprising of both Windows as well as Linux and Unix distros. In addition, there are several third-party vendors that provide virtual machine images for sale on the Amazon Marketplace. So in order to implement your EC2 instance and launch your virtual instance, you need to go through a series of steps. You need to initially select the Amazon machine image, or otherwise known as the AMI, which will comprise essentially of the operating system and any other additional applications that go as an image for your virtual machine. You then need to select the instance type, which will comprise of the size of the instance in terms of the virtual memory, the CPU, the network, etc. And then you need to provide various configuration details as to how and where you want to deploy your EC2 instance. Let's take a look at the AMIs first. So an Amazon machine image, or AMI, is essentially a virtual machine image much like you would have for Windows or Linux-based virtual machines on hypervisors like VMware and Hyper-V. An AMI is a template for the root volume of your instance that will comprise of the operating system, the state of patches or updates, and any applications that you may have pre-installed as part of that image. You can obtain AMIs from 4 separate sources. Ones that are published by Amazon Web Services via the AWS Marketplace. You can actually generate your own AMIs, which are virtual machine images of your own instances that you may have configured with custom settings, and you also have shared AMIs. Next, let's talk about choosing an instance type. So Amazon EC2 provides access to a variety of instance types, otherwise known as server versions, that comprise of the virtual CPU, the virtualization type that it's running on, the storage features, and any networking features as well. Okay, so let's actually visit this website to take a look at a little bit more detail of the instance types that we have available. Okay, so here we are at the instance type webpage on the Amazon website. So what you will notice is that you have a variety of instance types available to you depending on your specific business use case. And accordingly, you can select instance types from 5 separate categories. We have general purpose, compute optimized, memory optimized, accelerated computing, and storage optimized. For each of these categories, you can choose the type of instance that you want by selecting the model name, which will effectively translate into the available CPU on that instance, the available memory, and whether or not that instance is specifically designed for certain requirements like enhanced networking, for example. As you scroll down this page, you will also see typical use cases for the different instance type. So an M5 is one of the latest generation general purpose instances designed to provide balanced compute memory and networking resources. It also comes with 25 gigs of network bandwidth using enhanced networking and requires an HVM AMI. I'll come on to the virtualization types in an upcoming slide. But like I said, depending on your business use case, you will need to select the right instance type that fits the requirements of your business. So another example is if we're looking for storage optimized, then we have several instance models available, and you can see what each of those instance models is designed for. So in this case, we have the i3, and the typical use case is to use it for NoSQL databases like Cassandra or MongoDB. Now for the exam, it is not necessary that you know these in a lot of detail, other than the fact that there are 5 different categories of our instance types, and within these categories, it would be a good idea to at least have a rough idea about the different models that we have available. So with storage, we have H1, i3, and D2, for example. And if you can understand the basic use cases for each of these model categories or model subcategories, then that will go a long way for you. Okay, so next let's take a look at the virtualization types that are available to us. Now we have two of them on the platform. We have Paravirtual and Hardware Virtual Machine. So we'll take a look at HVMs or Hardware Virtual Machines first. You can run the operating system on top of the virtual machine without any modifications, as if it were on bare metal hardware. In addition to that, you have fast access to the underlying host system, and HVM AMIs are required if you want to take advantage of enhanced networking or GPU processing. Next, we have Paravirtual. Now, Paravirtual guests can run on host hardware that does not necessarily have explicit support for virtualization. However, they cannot offer enhanced networking or GPU processing. Now, in terms of which one to use, Paravirtual or HVM, well, historically, Paravirtual guests perform better with regards to storage and network because they could leverage special drivers for I/O, which avoided the overhead of emulating network and disk hardware. Today, however, we have PV drivers available for HVM guests, so operating systems that cannot be ported to run in a Paravirtualized environment can still see performance enhancements in terms of storage and network I/O by using them. In fact, HVM guests can give you either the same or even better performance than Paravirtual guests. Okay, so let's move on to talking about the available purchasing options that you have for your EC2 instances. Right at the top, we have on-demand instances where you can pay by the second for certain AMIs for the instance that you wish to launch, and essentially you can stop these instances and start up these instances at will, and you're only charged when the instances are actually running. Next, we have reserved instances. Now, this is where you can get significant discounts by making a commitment for 1 or 3 years. You are charged for the entire duration of that contract, whether the instance runs or is in a stopped state. And so it is vital that you actually understand whether an on-demand instance would be better or a reserve instance would be better. Ideally, make that decision based on how often or how long you are actually running those instances for. The other thing to note about reserve instances is that it is just a pricing model. Ultimately, when you purchase a reserve instance, what you need to do is you need to launch an on-demand instance that is of the same type, the same OS, in the same availability zone as the reserve instance that you had purchased in order to benefit from that significant discount. Next, we have scheduled instances. Now this is where you purchase instances that are always available on a specified recurring schedule for a 1-year term contract. We then have spot instances. Now, spot instances are very unique on the AWS platform. This is where you can actually bid for unused EC2 capacity, and you actually get them at really high discounts when you actually purchase the instance. So essentially what happens with spot instances, there is a spot price based on demand and supply, and that is going to be based on the operating system, the instance type, and which region you are actually trying to launch that instance in. And then you make a bid price. You actually bid for capacity. As long as your bid price is equal to or greater than the spot price, you will be able to purchase that spot price. The key important point to note is that the applications that you run on spot instances should not be affected by any kind of instance interruptions. What happens is that if the spot price goes above your bid price, then Amazon will interrupt your instance. Now, by default, that means to actually terminate your instance. However, you can now choose to have Amazon either stop the instance or put the instance into hibernation. The other key point to remember, and this is one specifically for the exam, is that the price that you actually pay for a spot instance is the spot price, not your bid price. Next, we have dedicated hosts. Now, this is where you pay for physical host that is fully dedicated to running your instances, and this enables you to actually bring your per socket, per core, or per VM software licenses to reduce cost. So, if you are an enterprise customer with a volume license agreement with the likes of Microsoft or similar, you can actually bring those licenses across to the Amazon Web Services platform, and in order to use them, you would need to provision dedicated hosts. Next, we have dedicated instances, which is where you basically pay by the hour for instances that run on single tenant hardware. Right, so that brings us to the end of this video, the course.